So, you've got a Ford, and the code P0194 just popped up. Yeah, that can be a real headache. But today, we're going to decode this tricky error and figure out exactly what your car is trying to tell you. Let's get right into it. All right, so there it is. That dreaded check engine light is glowing on your dash. You've plugged in your scanner, and it spits out the code P0194. You're probably a little frustrated, but don't worry, you are in exactly the right place. We're going to walk through this step by step.
First things first, what in the world does this code even mean? Well, P0194 stands for Fuel Rail Pressure Sensor A Circuit, intermittent/erratic. That's a mouthful, I know, but basically it just means your car's main computer is getting some really confusing or inconsistent signals from the fuel rail pressure sensor. It's like a bad phone connection.
To get to the bottom of this, we're going to have to play detective. We've got 4 main suspects, 4 potential reasons this code is showing up, and we're going to investigate each one to find the real root of the problem.
Now, here's the thing you really need to know about this code. The source material points us squarely in one direction. The issue is almost always electrical. So put down the heavy wrenches. We're not going to be pulling the engine apart just yet. Instead, we're going to methodically hunt down these 4 possible electrical faults to find our culprit.
And here's our case file. This table lays out our 4 suspects and the basic game plan for each one. We've got something called an open circuit in a couple of places and 2 different types of short circuits. Think of this as our roadmap for the investigation. So let's start with the most likely problem area.
Okay, our investigation begins with the fuel rail pressure circuit, or FRP for short. The signal that's causing all the trouble starts here, so it's the most logical place to start looking for clues first.
So, our first suspect is what's called an open in the FRP circuit. The easiest way to think about this is to imagine an electrical circuit is like a racetrack. An open is like someone came and took out a whole section of the track. The electricity can't complete the lap, so the signal never makes it back to the computer.
So, how do we find this break in the track? It's a simple 2-step check. First, you're going to grab a multimeter and check for voltage. Is power even getting to the sensor in the first place? Second, you'll check for continuity to see if that racetrack is actually complete. If you find the break, congratulations, you've found your problem.
And hey, listen up, because this is absolutely critical. Our source material gives us a very, very clear warning. Never, ever, ever try to repair this circuit while the engine is running. Safety first, always. Turn it off.
All right, what if the track isn't broken? Well, let's move on to our next 2 suspects. A short in the FRP circuit. If an open circuit is a broken track, a short circuit is when the electricity takes a dangerous shortcut it's not supposed to, jumping over to another wire where it doesn't belong. And that can cause all sorts of chaos and confusing signals. Now, we're looking for 2 types of these shortcuts. A short to voltage means the sensor wire is accidentally touching a wire with full battery power. A short to VREF means it's touching a specific low-voltage reference wire. Think of VREF as the computer's special, super precise measuring stick. Now, these are different problems for sure, but the good news is we find and fix them the exact same way.
So, the solution is just a good old-fashioned hands-on inspection. You need to get in there and carefully trace the FRP wiring harness. You're looking for any signs of damage. This happens a lot where a wire has been rubbing against a hot engine part or a sharp metal bracket and it just wears away the insulation. If you find any chafing, melting, or a clear break where wires are touching, that's your smoking gun. Just repair or replace that section and you should be good to go. Okay, so what if you've checked that entire FRP circuit and you found no opens and no shorts? Is our investigation over? No, not yet. Now we have to turn to our final suspect, an issue with something called the SIG-RTN circuit.
Our last potential culprit is an open in the SIG-RTN, or signal return circuit. This is basically the ground wire for the sensor. It's the return path. So if this return path is broken, remember our racetrack analogy, the signal has nowhere to go. And that can also cause that intermittent or erratic reading that triggered the code in the first place. And just like with our very first suspect, the test here is for continuity. You'll get out your multimeter and make sure there's a nice, clean, unbroken path from the sensor all the way back to the computer's ground. If there's no continuity, you've found your open circuit and you can get to work on the repairs. And look, I know I'm repeating myself, but I cannot stress this enough. The source material reminds us, one last time, For any of these electrical repairs, the engine absolutely must be turned off. It's a simple rule, and it's the one that keeps you safe.
All right, we've done it. We've investigated all 4 suspects, we've covered opens, we've covered shorts across 2 different circuits, so now let's put it all together into your final diagnostic action plan.
So here's the entire process, laid out nice and simple. First, you understand what the code is telling you. Then, you systematically check for an open in that main FRP circuit. If that's all good, you inspect for any shorts in that same circuit. Still nothing? Okay, move on and check for an open in the SIG RTN circuit. And of course, our golden rule that covers everything. Always work with the engine off.
See? By breaking down P0194 into these 4 electrical suspects, what seemed like a really complex problem becomes a totally manageable process of elimination. You now have a clear diagnostic map to follow. So, the only question left is, are you ready to grab your tools and close this case?